Once again, welcome back to the Math Revision Made Meticulous video series. Topic: Continuity and Differentiability. Differentiation of inverse trigonometric functions. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Before we start, let us recollect the rules of derivatives and some formula of differentiation. If u and v are two real valued functions, u plus or minus v the whole dash is u dash plus or minus v dash. Differentiate them and then add the derivatives. And product rule, u into v dash v whole dash is u v dash plus v u dash. Keep the first, differentiate the second, plus keep the second, differentiate the first. Division rule, u by v the whole dash is v square at the denominator, v into u dash minus u into v dash. How to remember it? Denominator square in the numerator, denominator into numerator derivative minus numerator into differentiation of the denominator. Well, let us very quickly recollect the formula of differentiation. They are very useful in doing problems. For x power n, derivative n into x power n minus 1. For root x, 1 by 2 root x, e power x, a power x log a, log x 1 by x, sin x cos x minus sin x, tan x secant square, cosecant x minus cosecant x cot x, secant x tan x, cot x minus cosecant square, sin inverse 1 upon root 1 minus x square, cos inverse minus 1 upon root 1 minus x square, tan inverse 1 upon 1 plus x square. Now, before we go further, let us just recollect the inverse trigonometric function properties, which you have studied in our chapter number 2 and so on. Okay, sin inverse of sin x is x when x belongs to the principal branch. Cos inverse, cosecant inverse of cosecant x is x. Cos inverse cos x is also x. Secant inverse secant x is x. Tan inverse tan x is x. And cot inverse cot x is x. Good. Now, another property is sin inverse 1 by x is cosecant inverse x. If you want to convert sin inverse and cosecant inverse, it can be used. Cos inverse 1 by x is secant inverse 1 x. And tan inverse 1 by x is cot inverse x. The next property is regarding the negative angle inside, negative value inside the sin inverse. Sin inverse of minus x is minus sin inverse. Tan inverse minus x is minus tan inverse. Cosecant inverse minus x is minus cosecant inverse. But cos and secant and cot will have only pi minus. Therefore, cos inverse minus x is pi minus cos inverse. Secant inverse minus x is pi minus secant inverse. Cot inverse minus x is pi minus cot inverse x. Okay. Another property is sin inverse x plus cos inverse x is pi by 2. Similarly, tan inverse x plus cot inverse x is pi by 2. Cosecant inverse x plus secant inverse x is pi by 2. Another interesting property about this formula, tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy. Similarly, if you have tan inverse of x minus tan inverse y, it is tan inverse of x minus y upon 1 plus xy. These formulae derived from our tan x plus y and tan x minus y formulae only. Well, now another property is how to express tan inverse x in terms of sin inverse, and how to express tan inverse in terms of cos inverse, how to express tan inverse in terms of tan inverse. These are all the formula which already we have seen in multiple angle formula are being used over here. Sin 2x formula is used to get the first one, cos 2x formula is used to get the second one, and tan inverse formula is used to get the third one. But we will go for how to do this differentiation. Very simple. Use formula or proper substitution to reduce the inverse trigonometric function to its simplest form. Inside the sin inverse, cos inverse, tan inverse, we will try to reduce it so that we can get a easy expression. We can do the differentiation directly. Suppose if you have used substitution, do resubstitution after simplification is over. It is very, very important. Suppose when you put x is equal to something in terms of theta, at the end you may get the final answer as theta by 2, but don't directly write the answer as 1 by 2. Here most of you will be confused, but be careful. When you have done substitution, you have to do resubstitution. And after the resubstitution, you have to get the differentiation. Fine. Therefore, you have to first use the formula to reduce it or use proper substitution to reduce it. If you have used a substitution, don't forget to do the resubstitution before you are doing differentiation. Fine. Before we go further, let us quickly recollect the formula of inverse trigonometric function differentiation. Sin inverse x is 1 upon root 1 minus x square. Suppose you have chain rule. This is the chain rule. Already we have discussed in our previous video. Sin inverse root x is 1 by 1 minus root x whole square differentiation of root x. Similarly, sin inverse of tan x also you know how to do. 1 by root 1 minus tan x the whole square into d by dx of tan x. Similarly, for cos inverse x, it is minus 1 upon root 1 minus x square. Suppose you have anything function of function there, then this is the method to do. Because in some problem when you do the resubstitution, you may not get cos inverse x, you may get cos inverse of root x also sometimes. Or you should know how to do the chain rule for sin inverse, cos inverse and tan inverse. This is the chain rule for tan inverse. Tan inverse x square 1 upon 1 plus x square the whole square into differentiation of x square. Tan inverse of sin x will be 1 upon 1 plus sin x the whole square into d by dx of sin x. Well, we will now move on to problems now. First, before we go further, let us first try to understand that there are certain substitutions for simplification which can be remembered, but these substitutions normally will, most of the majority of the problem will get solved using these substitutions. Suppose you see a square plus x square, you try with x is equal to a tan theta. When you see a square minus x square, you try with x is equal to a sin theta. When you see x square minus x square, you try with a secant theta. These substitutions will reduce the expression inside sin inverse, cos inverse, tan inverse to a better one. It will get simplified automatically. Sometimes you may get root 1 plus x or root 1 minus x. Be careful. Here you put x is equal to cos 2 theta. Some book will tell that you put x is equal to cos theta also. More than enough. Therefore, you can put cos 2 theta. No submultiple angle will come. Suppose if you see 1 plus x square, 1 minus x square inside square root. I repeat once again. If you are getting without square root 1 plus x square, you will go to the first substitution. X is equal to tan theta. Suppose if it is inside the square root, then you take x square as cos 2 theta. Fine. Note down these substitutions. This will be highly helpful for you to at least start the problem. Well, now let us go on to moving problems now. I already told you there are certain problems in tan inverse where no substitution. We will try to simplify using properties of trigonometric functions. Now, whenever you have tan inverse, try to get tan inside. Cos inverse, try to get cos inside. Sin inverse, try to get sin inverse. Then only you can use that formula. Sin inverse of sin x is equal to x. Cos inverse of cos x is equal to x. Tan inverse of tan x is equal to x. Fine. Now I am starting now. I have a formula. 1 minus cos 2 theta is 2 sin square. 1 plus cos 2 theta is 2 cos square. But here what is there here? You are having only 1 minus cos x, where it will become 2 sin square x by 2. And 1 plus cos x will be 2 cos square x by 2. Fine. Therefore, what will happen to the bracket now? It will become sin x by 2 by cos x by 2, because inside the square root, it is tan inverse of tan x by 2. Therefore, the answer is 1 by 2. Very simple. Here we have used the formula of 1 minus cos 2x and 1 plus cos 2x. Fine. Let us go to the next question. Sometimes you have to put substitution. Here I am taking a problem where you have to do by substitution. Here I am getting a square minus x square. Already told you that you can try with a is equal to sin theta. But better when you do the substitution, please write the resubstitution and keep it ready. Therefore, when I take x is equal to a sin theta will be x by a. Therefore, theta is equal to sin inverse x by a. Fine. Let us go to the y now. It will be y is equal to tan inverse x upon root a minus x square. It is nothing but a sin theta by root of a square minus a square sin square theta. Therefore, 1 minus sin square is cos square. I am using it. You are getting a sin theta by a cos theta. Therefore, it is theta. Therefore, y is equal to tan inverse of x upon root a square minus x square is nothing but sin inverse x by a. Now, you have to differentiate the right hand side. Again, I repeat, I have done substitution, simplification, resubstitution. Do the differentiation now. Sin inverse x is 1 upon root 1 minus x square. Therefore, 1 upon square root of 1 minus x by a the whole square. But you have to differentiate x by a once again by using chain rule. Therefore, its differentiation is y 1 by a getting cancelled. You are getting the answer. For dy by dx is 1 upon root a square minus x square. Fine. Let us go to question number 3. Once again, this is a problem of substitution because tan inverse of root 1 plus x square minus 1 by x. Let us try with that tan theta, because a square plus x square substitution is x is equal to a tan theta. Before we go for that, let us try to fix the resubstitution. Theta is tan inverse x. Ready? Therefore, I am replacing wherever x comes by tan theta. 1 plus tan square inside square root minus 1 by tan theta. What is 1 plus tan square? Secant square. For secant theta minus 1 by tan theta. Now let me replace it secant and tan in terms of basic trigonometric functions. 1 by cos minus 1 by sin theta by cos theta. Take LCM in the numerator. It is 1 minus cos theta by cos theta. Denominator sin by cos, cos getting cancelled. For I end up with 1 minus cos theta by sin theta. Once again, we have to make use of the formula of multiple angles and submultiple angle which is studied in lower class. 1 minus cos 2 theta is 2 sin square. Therefore, 1 minus cos theta is 2 sin square theta by 2. Sin 2 theta is 2 sin theta cos theta. Therefore, denominator sin theta to be written as 2 sin theta by 2 by cos theta by 2. Well, therefore, tan inverse you are making use of it. 2 sin square theta by 2 by 2 sin theta by 2 by cos theta by 2. Sin theta by 2 by cos theta by 2 is tan theta by 2. Therefore, you are getting theta by 2. But don't differentiate directly because we have done substitution. What we have to do? We have to do resubstitution. I am doing resubstitution because theta is tan inverse x. When you do the differentiation, it is 1 upon 1 plus x square. Fine. Let us go to question number 4. Find dy by dx if y is equal to tan inverse of root 1 plus x minus root 1 minus x upon root 1 plus x plus root 1 minus x. Already we have discussed that whenever you see 1 plus x, to x is equal to cos 2 theta. If you take cos theta, you will get submultiple angle formula. When you take cos 2 theta, directly you can do. Anyway, let us take x is equal to cos 2 theta. 2 theta is cos inverse x. Therefore, theta is half into cos inverse x. As I told you earlier, better have the resubstitution ready before you start the problem. Good. Let us start. Square root of 1 plus cos 2 theta into square root of 1 minus cos 2 theta, both numerator and denominator. And we are having a formula for 1 plus cos, it is 2 cos square theta. 1 minus cos 2 theta is 2 sin square. Put it in the numerator and denominator. Root 2, root 2, root 2, root 2 cancel. Cos theta minus sin theta by cos. Well, we end up with y is equal to tan inverse cos theta minus sin theta by cos theta plus sin theta. Already we have discussed whenever we have tan inverse, inside you should get tan of something or cot of something, whatever maybe. Therefore, what we are going to do is divide numerator and denominator by cos. What will happen to it? Cos by cos minus sin by cos. Cos by cos plus sin by cos. What is cos by cos? 1. Sin by cos is tan. Now, once again, we want to use the formula tan of x minus y. For that, we are having the idea that tan pi by 4 is 1. Wherever 1 comes, replace it by tan pi by 4. For it will become tan pi by 4 minus tan theta by 1 plus 1 into tan theta, therefore tan pi by 4 tan theta. Therefore, it looks like the formula tan of x plus y or x minus y, whatever may be. Therefore, it is a tan of pi by 4 minus theta. Therefore, it will be pi by 4 minus theta. Now, you should not do the differentiation now. You should not do the differentiation now. Why? Because you have to do the resubstitution. Do the resubstitution, it will become minus half into 1 upon root of 1 minus x square. Therefore, this is the final answer. dy by dx is 1 by 2 upon square root of 1 minus x square. Well, let us go to the next question. Differentiate sin inverse of 1 upon square root of 1 plus x. Little bit tricky question. Here, when you just start with the substitution in any other fashion, it can be done. You can take x is equal to cos 2 theta and you can do also. But now, suppose when you take sin inverse, I want cosecant inside or sin inside. Therefore, I take the substitution as cot square theta because 1 plus cot square is cosecant square. Cot theta is root x, therefore theta is equal to cot inverse root x. Therefore, sin inverse of 1 upon root 1 plus cot square. Therefore, this is sin inverse of 1 by cosecant square theta. Sin inverse of 1 by cosecant, which is nothing but sin inverse of sin theta. Well, what is theta now? Cot inverse root x. We have to differentiate cot inverse root x. For that, what formula we have to apply? Chain rule. The chain rule is cot inverse x differentiation is minus 1 upon 1 plus x square. So, minus 1 upon 1 plus root x the whole square into d by dx of root x. D by dx of root x is 1 by 2 root x. Therefore, I got the final answer. Now, this problem can be done by making use of x is equal to cos 2 theta also. Then, in that case, what will happen? You will get sin inverse of some cos you will get. Then that cos to be converted into sin. Anyway, That can be done by that method also. Well, therefore this is the answer for this by putting x is equal to cot square theta. Well, now thank you. Success is dependent on efforts. All the best.